Hi everyone, my name is Ledell Thomas.
I'm Cynthia, Suarez-Harris.
And we're from Prairie View University. We were the first place winner in single urban family home, and we also were the grand winners. We're presenting our modular home that we designed for our project. And we will also be continuing the Solar Decathlon. So this is just showing the rendering of our project, and it shows the proposed location, which is in Independence Heights. It's one of the historical Black neighborhood that's in Houston, and we decided to do a studio, 2-bedroom and a 3-bedroom, and it just shows the front landscaping of it and how we're going to utilize also community center. Right here, we decided to use resiliency, affordability, sustainability, and also community in our key points. And as you can see in here, we decided to use this as a reference of being actually saved to and not rescued from, because in recent years we've been having a lot of storms, especially with Harvey, that hit the community really, really bad. We decided to design for that. Right here just shows graphs of how actually the community actually started suffering during 2001, which was Tropical Storm Allison. And as you can see right here, we use a double lot because the city of Houston allows you to have 2 homes per lot. So we decided to put those together in order to build a pocket community. And right here just shows the site. Right here we decided to use a low impact development to preserve as much green space as possible. And as you can see right here is the community center, and then the other 3 homes, which was the studio, the 2-bedroom and the 3-bedroom. We decided to do this as well. The only sustaining pavement right here is actually just the sidewalks. Everything else is permeable paving. And then in this slide, you can see right here, we decided to use a fly roof system, which is a double roof system. Of course, in Houston, you have a lot of hot, it's humid, so we decided to do that to prevail less radiation to the building and to create less of a thermal bridge. And that accounts to using less energy use and to also get to passive house. And in this slide, you can see how we use different modularity standpoints in order to increase flexibility. And to add to it, we wanted to make sure that each home is able to add an addition over time, because we make this affordable as possible, so to pertain to our customers. And then also we wanted it to have an open cavity by using rigid installation. As you can see right here, by using rigid installation, you have it on the outside, and you don't have that pink fluffy stuff on the inside. It creates a better flexibility of space, and we are going to also design furniture to actually maximize the space as well. Okay, and this just shows our constructability phase of how it's going to happen. We're going to design these and build these with our design build program that's inside of our school. We actually have a fab lab, and we're going to use partner up with students and actually build this thing, and then we're going to ship this off, load it into a dock, and then the truck is going to go into the neighborhood, put it onto a crane, and then slide it in while the roof structure is getting built. It's going to get slid in, and then it's going to get positioned on helical piers. And this just shows the sequencing of how that's going to happen right here.
So we made sure to target the homeowners that lived in the neighborhood of Independence Heights. We found that they typically earn 50 to 80% of Houston's annual median income. So this is a breakdown of what their costs are, and it does show that they're not spending more than 38% of their salary on housing costs. What we did is we offered different options on purchasing the home. So we pretty much left it up to the owner to choose the size of their home, and they can then upgrade to the home's energy performance according to their budget. In partnering with a CPC, we also offer different land ownership options that would lift the burden of housing costs. On the energy modeling front, we made sure to energy model the home as much as possible, and we decided on the double roof system. And from then, we used more software to dial in on insulation values, as well as the use of the fly roof. That allowed us to eliminate thermal bridging, and that way we could have a continuous air barrier and thermal boundary. Sorry. So our wall assembly was, some of the materials were changed to meet different standards, ranging from Energy Star all the way to Passive House and FEMA 499. Some of the things we did to address that was include triple pane windows or impact resistant glazing. And in this slide you can see for the Energy Star we use a Panasonic back fan. We did remove that when we upgraded to a Passive House home. So, and they were using an ERB, a dehumidifier, a ducted mini split as well. That was right sized to meet the size of the condenser. We did keep a tight wet core, and we did meet the water sense requirement. All of our lighting and appliances are Energy Star LED as well. Okay, and one of the things that we were trying to propose was community solar. So our largest home only consumes about 5.2 watts of energy. However, the fly roof does have solar panels mounted on top that produces about 27.3 kilowatts. That would put us in the spot where we can generate electricity for the rest of the neighborhood and create a resilient community. So overall, the standards that we set in the beginning of our design to meet economic, social, and environmental resiliency, we did meet that. We had an elevated home with a fly roof, reducing the solar heat gain. But anyways, just imagine having this kind of peace of mind in the middle of a storm. That's what we felt we did, because they don't have to rebuild. They have strong homes. They don't have to purchase anything, so financially they're not wasting their precious resources that they need. So that's ultimately why we believe in our project, because we feel that we've come up with a solution to transform our community, and we are thankful to be here because we can see how you guys are also doing the same thing. So thanks for the inspiration.
Any questions? Where had?
Can I ask a question?
Yes.
First of all, congratulations on a beautiful job. I was curious, obviously Houston could be hit by a hurricane. What happens to the fly roof in that situation? Did you elaborate on that?
Well, first, it's structured down by your local piers, so it's rooted down very securely, and also the module home is fastened to it, right?
Yeah, it's welded to a base that connects it's anchored to the fly roof and the helical pier. So it's all one structure. Mm-hmm.
Any more questions? Yeah.
I understand you have a construction facility as well.
Oh yeah, Fab Lab.
Yeah.
And how likely is it, or how soon could these possibly be built?
Well, if you follow us on the Fly Flat on Instagram and Twitter, right now, we're in the midst of doing our lab home, which is like a tiny concept of it right now. We're going to showcase that for our local community. And once we have that put together, we can work out the kinks and start actually putting it into production mode. So yes, as soon as possible.
We're building now.
They have a website you could order it on.